value, but yeah. It's a very huge number. So, generally speaking, you'll find that in calculations, most people just use floats. Because do you know what is going to happen? Let us say you declare something. If you say int a is equal to, okay, let's say you create three variables, a, b, c. Then you say a is equal to 3, b is equal to 2, and then somewhere along the way, you're processing, you're saying c is equal to a divided by b. But remember, c is an integer. You declared it as an integer. You know what's going to happen? No. Okay, test it and see. So that's little homework for you. You're going to test and see what's going to happen. But generally speaking, most people are doing anything involving computations. Just generally, just use a float. Because remember, when you have an integer like 7, as a decimal, it is 7.0. So that means a float can handle both decimals and integers. So most people, when they're doing something involving computations, they just use float. You know? Just use float. It's just easier, so you don't have to worry. It puts so many things away. Because you see, while you are using an integer, you realize you have got to make sure that it's something less than, okay, within that range of 32,000, 32, negative positive 32,000. And yet it's possible for it to have something bigger like 1,000,000, and an integer can't hold that. But when you use just a float, it can hold it. Yeah.
So does that mean that if I expect to have extremely large values, I will have to start with double rather than float?
If you know it is a very unique opportunity. But yeah, you can either use a float double, doesn't really matter. They're very rare situations, but yeah, float and double are more commonly used. Although, we are going to look at something referred to as loops at a certain point, and when it comes to loops, you will have to use specifically integers for something special required there. Okay. All right. There are questions or something? Someone to share? Okay, so you should be familiar with defining variables. So, you know, we just put the variable type and then the variable name. Just say int total. You've declared a variable called total of type int. Okay, so int is the data type, variable and total is the variable name, and you declare it, you make sure you have a semicolon there. You can do this on different lines, you can do this on the same line. It's okay, you won't use a map for this is fine, absolutely fine. So here is a quick example. We'll have our example that shall try out. Just follow along with this one here. So, step one, you like, okay, int event. So you have declared a variable called event of data type int. So it goes into your memory, it reserves a slot where it's going to save anything associated with event. When you say car, it creates one for heat. Float time, it creates one for that. So my pointers are a little out of alignment, but it still makes sense. Then when you say now event equals 5, it comes in here and it puts 5 in its rightful place. It does the same for the character there bit, and it does the same for that time there. Then you, after you can do your whatever, you print up the winning time in this and whatever, is that I showed you that you put this here, referred to as a format specifier. We're going to look at them just a little bit ahead, but I think you should remember we used %d because we're dealing with integers. There is %f for dealing with decimals and floats, and there's %c for dealing with characters, and they are others. Now, something very sensitive about C is that C is a very powerful programming language, and a lot of its power comes from the fact that it's very close to the hardware. Basically, C, just like I talked about memory, C directly interfaces with the memory. Other programming languages have some other layers on top of them before you get the hardware. Now, when you open a program, remember your RAM, you have a RAM of say 2 GB, 1 GB, 16 GB, 32 GB. Over the course of your day, doing whatever you're doing, your RAM is, the cells in your RAM are reused. For example, if you're using a certain bunch of cells, you close the program, you begin using another program, it will reuse those same cells there. Now, it's very, very important for you to understand this. When it's using those cells, it saves some stuff in those cells. When you close the program, whatever is saved in those cells is not necessarily cleaned off. It remains that the program has ended, but then the data which the program was using, which is saved inside those slots there, is still there. So, when you, for example, when you now create something like int event, the slot which has been reserved for event is not necessarily empty. It may have something from the previous program which was using that slot there. Only when you now say event is equal to 5 is now whatever is there replaced with a new value. So when you create a new slot again like this here, when it gives you like when you declare hits, this slot here is not necessarily empty. So you have got to be very, very careful when you're doing your computations, because if you begin doing computations, before you have assigned values to those things there, it's going to use whatever random value was there. So imagine there was something like 1,500,000 in there. It's just going to use it because that's what it has found there. It's going to use whatever value is in there. So you have got to be very, very, very careful. Other languages take care of this. C does not necessarily take care of this. So whatever is in there, we refer to it as junk until you assign something to it. So, if you declare variables, you find it fit, we are going to see something about summation. Normally, something like total and summation, when you declare it, you immediately assign a value to it. So you declare total, and you say total is now 0. So you declare things, you can do it in one line. You can declare and assign a value. So 8 event equals 5. So you have done 2 things in one line. This is not necessary, but there are situations where it is absolutely necessary. Again, I am going to give you examples where you're going to realize what I mean when I say it is necessary for you to do that. And yes, you can initialize more than one. It's okay. Just so you get not confused. Doing this all in one line is okay. The time when I said you lose marks is a complex statement where you have a semicolon and you begin another one with a semicolon. That is when you lose marks. But this is still just one statement. So it is fine for you to do that in one line. Yeah. Now we come to the format specifiers. The ones who did the examples with me last time, I believe you're also still familiar with this. Familiar with %d. That's the format specifier for integers. You can't have, say, %i. They are very specific. It's %c for characters, %d for integers, %f for a float, or double. Okay? Don't get confused and think %d might be for a double. Nope. For both the float and the double, we use %f. Then we have %e, and there are others like %s, but these are the main ones that I would like you to know about. So just something to notice, which again, if you did examples with last time, you already know this stuff here. If you say something like printf, the value is, you put %d, you're using it as a placeholder for an integer. So this placeholder here will be replaced by what you put here. Notice there's a comma there, and this will be assigned to that. So you'll have the value is 8. Okay, so make sure that makes sense to you. If you have more than one, it's going to assign them respectively as they were declared. So if you say something like this, if you have %c, something, something, %d, something, something, %f, it's going to replace them in accordance to the way they were declared. So the first one will get this, the second one will get this, and the third one will get that. So those are format specifiers, and here they are: C, D, F, and E with the % symbol in front of them. Now there's something referred to as a field width specifier that you also need to know about. And yes, if in your first test, these are things that always will ask. So when there's some homework I'll give you to do, I will not mark it. It will be up to you whether you want to do it or not. If you decide not to do it, we shall know from the test. So here, remember when we're saying things like we're printing something like say printf, and you're putting whatever you want in there. Print this, put whatever you want in there. But now, sometimes you want to have control over exactly how big or small whatever you're writing is. And for that, we use a field width specifier. And it's very easy. The first one we will look at here is just the number of decimal places. Because, okay, you may want, you're doing a calculation and say you get a number which is very big. For example, here you can see we have float v as 5.4633. You can specify and tell it, okay, you want this to. Remember, when you're printing out, ordinarily, you just say %F. This is how you normally say. You just say %F, and it's going to replace this with that. But instead of just saying %F, in front of the F, you can put a number. When you put, you can put a dot number. So when you say .1, you're saying write it to 1 decimal place, 2 decimal places, or 4 decimal places. So this is how you state the number of decimal places. So what could happen based on this is, I can give you something like this, and here you can see I've given you a value like that, and then what I say is give the output generated by that. So it's up to you to realize, say, because there is 0.2, that means whatever is going to come out is going to be up to 2 decimal places. But also notice there's something like 5. So this 5 is not like 5.2 decimal places. 5 is something I'm going to show you now. So you can see there's also 10 here with the E. It has some special meaning. So now the 0.2 is for decimal places. The 5 is for the width of what the display area is going to look like. Let me show you what I mean by that. You can notice, look at those as okay, so now we have our percent here. Remember, ordinarily this is just %D, okay, but now we have a 6 here. Notice, okay, in this case I don't have the 0.2. The decimal specifier only works when you have a point after the point something, the dot. The 6 here is something completely different. Okay? It is a field with specifier. So for example, when I have 6D, it's going to come and create like a holder for 6 spaces. 1, 2, 3, 4, 5, 6. And then the value of entered in is going to be put, formatted to like right adjusted at this end here. If you put a negative there, like -6, it's going to put it here at the front. Okay, so make sure you know that, because there's a question I can guarantee is coming about that. So similarly here you have 4D, there are 4 spaces. Now you can combine both the space specifier there and the one for decimals, and you can have something like 6.2. So 6.2 will mean 6 spaces, 2 decimal points. Okay, so keep that in mind. Yeah.
So, for example, the question you just showed us where you specify that actually it has 5.2, but the original integer was 5.675. So does that mean that if you round it off?
Yeah.
So it would generate then the output as 5.68.
it is going to round it off. Okay, yep. I don't know how, not doing well with time, but we shall do some examples where you're going to see that.
Then, so you have just stated, for example, there where you have percent 6D, that if you add a 0.2, it will reserve for 2 spaces. I thought that adding the point is only kept for if you are using float, which would be the F. Would it allow if I add the 0.2 to a D?
You have 0.2 to a D. Okay, in this case we have integers. So no, it won't here. I'll just try it out and see what's going to happen. But let's first do this and then hold on. Let me see how much more stuff. Because I really want us to cover the scanf and then we go. Hold on. Wait. I'll do some examples. Okay, shall not go there. Let's cover up to the scanf statement, and then we're going to try all different variations of that, so you can see. All right. So here is an example to show you why we may want to do this. Because in this case here, like you were asking, we now have at least we have a float. Okay, so you notice that if we just print out everything as is, you look at what happens to our output. Our output is sort of it's organized all over the place, but you may want to have a tidy output like this. So you can notice everything is aligned to the left, to the right, okay, and it has a very specific number of decimal places. So this is one use of those format specifiers for space and decimal places. So because you may be doing some calculation, you don't have control over how big or how small it is going to be, how many decimal places are going to be there. So by using format specifiers, you can actually control that, and you can have a pretty tidy output. So you can see what happened here. We have, say, 8.1F. So the 1F is 1 decimal place. The 8 means they are 8. Like, imagine here there is some kind of a box with 8 spaces. Each of those spaces there holds one character. So right now, 3.0 is actually 3 characters. So there is a 0 in one of those boxes. There is a point here in one of the boxes, and then another point here. And then now we have 5 more empty ones on that side there. So by doing things like that, since we keep it constant, 8, 8, 8, 8. So we have 8 boxes, 8 divisions in there, 8 of them in there, 8 of them in there. So you can imagine if you have 8, 8, 8, 8, 8, that means we can control how everything looks. And look, think of it if it's confusing you, like an Excel sheet. Why weren't more of you interested in going for the trips? I have 3 more trips. Okay. It is well. Even during the hackathon, your friends were there winning money. Where were you, Paul? There was a hackathon. Where were the rest of you? People were winning money. Do you know one of your colleagues won some money? A group from here, first years. Did they share the money with you?
So the thing is, every semester we have these trips that we organize, and we go to some places which we hope will inspire you guys. So you have to make sure you're observing what's happening in university. Sometimes we only tell people who are participating in our projects, people who are showing interest in what's happening around the university, in the department. So if you're also hiding, we shall also hide from you.
All right, so if we have something like, say, so normally we have something like percent, say, F. So when you have percent F as
well, there's money to be won. Like say the top 3, the top 5 groups are each going to be able, they're going to be supported with up to 5 million to develop what they propose at the hackathon. When you graduate eventually, this is what makes you different from everybody else, the projects that you did. So I hope we shall see more and more of you participating.
okay, so ordinarily we have say percent F. So percent F is a format specifier for decimals, and it's going to be both floats and doubles. All decimals are going to be handled with percent F. Now, let us say we have a value in here like 6 point maybe 3 4 3 2 1 4 3 2 1, and then we have say 8 point, because would have a percent D like this. Let me use the same example here to make it easy for you to get what number they use here. Just go on. All right. So let's say we say percent 8.2 F. Then what's going to happen is we have 6.4321. So this here is going to be taken, and then we are going to put this within 8 format, within 8 width, so 8 spaces. So this 8 here is 1 2 3 4 5 6 7 8. So it's going to be in here, and it's going to be in here adjusted completely to the right. So in our case here, I think, okay, let's first ignore the decimal place. It would have been something like that. Okay, there it is. It would have been like that. But we also have a point 2F. The point 2F is talking about the number of decimal places. So in our case here,
decimal place 1, decimal place 2, this is where it is supposed to end, okay? And this will go back in there, adjusted to the right. Okay, Excel is not the best for this. There you go. So now you have it there, 2 decimal places, and 8 with 3, 4, 5, 6, 7, 8. So that's how your 8.2 will be. So any other values you enter using this same one here, because it's always going to put everything right adjusted. Then even if you have something a bit bigger, like maybe a 2 there and a 7, it is going to make sure it is right adjusted. So all of your things are going to appear right adjusted, and it's going to be a little bit more tidy. So it will make more sense. We are going to look at examples. Okay, so there we go. If you put a negative in front of it, then it's no longer right adjusting, it's now left adjusting, okay, by putting a negative there. And then the final thing I want to talk about today, and this is something very, very important. When you're programming, remember I told you we have input, we have processing, we have output. Now, input in C, one of the common ways to do it is using the scanf statement. Now, you need to look at this and basically just memorize this this syntax here. Much later on, at the very end of our course, we are going to look at pointers, and it's going to make some sense to you, especially why we have that there. So, if you want to read a value from a user, first, this is how you do it. You can ask them, enter your age in years. Now, after you ask them, they're going to enter. But after you enter something, how are you going to get it from them? Okay? Use a scanf statement. And the syntax is just like this. Scanf, basically F actually means function here, the scan function. Print F was the print function. So scanf, open, close brackets, format specifier. In our case, we want to read it as a decimal. So the advantage of using the %f there is whether they enter a decimal, like they say they are 5.5 years old, or they enter an integer 5, it's going to be able to handle it. So you put the format specifier there, %f, then notice the comma, then 2 things, the ampersand, okay, the and symbol, and where you want to save the value. It's written like this, it's always like this, it's not written any other way. Let's look at an example now.